Good morning. Today we will be discussing graphing and attributes of rational functions. This is Chapter 8, Section 2 in the Big Ideas Algebra 2 book. Okay. For the TEKS, this is TEKS 2A.2A. We will explain characteristics of a rational functions graph. We're going to find the domain, the range, and the asymptotes of rational functions. So first we're going to start off with the parent function. This is what the parent function of a rational graph looks like. F of x equals 1 over x is our equation. So that's our parent function equation. Now in this format, notice that there's an x on the denominator and there's a number on the numerator. When it's in this format, to find our asymptote, we're going to set our denominator equal to 0. So in this case, it's x equals to 0. That is a vertical asymptote that'll go through x equals 0. To find our horizontal asymptote, we're going to look for the number that's after the fraction. Well, as you can see here, there is no number after the fraction, which is why we get y equals 0. So an asymptote of y equals 0. Now don't forget, an asymptote is a line that the graph is going to approach, but it's never going to get there. It's going to get really, really close, but it can never touch the asymptote, can never cross the asymptote. So basically that determines your domain and range. Our domain and range for these are going to be all real numbers except for those asymptotes, okay? So as you can see on the bottom here, the domain is all real numbers except where x cannot equal 0. The range is also all real numbers except where y cannot equal 0. The asymptotes are imaginary boundary lines where the graph cannot touch. Okay. So here is an example with more numbers besides just the parent function. So again, in order to find the domain is all real numbers except where your denominator equals to 0, which is this arrow right here. So we're going to take that denominator and we're going to set the denominator equal to 0. Okay? We do the inverse operation. We add 4 to both sides. We get x equals 4. So our domain is all real numbers except x cannot equal 4. There's a couple different ways to write this. If we wanted to graph it, and let's say here's 4. Well, this is negative infinity. This is positive infinity. And basically, it's all real numbers this way and this way. We could also write negative infinity to 4, both with parentheses, union 4 to infinity. My vertical asymptote, well, my vertical asymptote is my number that my domain cannot be. So it's that same number again. My asymptote is at x equals 4 because this graph can never cross at x equals 4. For my horizontal asymptote, which is going to affect my range, it's a number that comes after the fraction, okay? So this number right here is going to be my asymptote, my horizontal asymptote, and my range is all real numbers except for that number. So that tells me that y is equal to 3 for my asymptote. Which means my range is all real numbers except y cannot equal 3 because it's an asymptote. So here is your other asymptote. Now again, that's one way to write it. If we wanted to think about a graph-wise, it'd basically be negative infinity to 3, union 3 to infinity. Okay, we won't always write it both ways, but at least you've seen it both ways. Now, where do the branches of my hyperbola go? Well, since the graph is positive, when the graph is positive, and what I mean by positive is if there is no sign there, we already know it's a positive. If it's positive, it's going to go in the first and the third. Okay, now don't forget it's never going to touch the asymptotes, but it's going to get really, really close. Okay, we're going to do another one pretty quickly. Okay. Again, we always start off with taking our denominator, and we're going to set our denominator equal to 0. We have to get x by itself, so we're going to subtract 6 and then divide by 3. Subtract 6, divide by 3, you get negative 6 over 3, you get negative 2. So x equals negative 2. Now, when you graph x equals negative 2, that can help you remember, is this vertical or horizontal? This is your vertical asymptote. So your domain is all real numbers, except x cannot equal negative 2. My range is going to be that number right here on the outside, and range is always a y. So my range is y, so my asymptote is y equals negative 2. Asymptote is y equals negative 2. So my range is all real numbers, except y cannot equal negative 2. We're going to graph that. Now, is the graph positive or negative? Well, what sign is here? We don't have one, so we know it's positive. If it's positive, it's going to go into the first quadrant and this third quadrant. Let's go ahead and go on to the next questions. So these are going to be some quick questions. We'll just do a few of them, okay? Maybe we'll even mini sketch a couple of them. Remember, first step number 1 is always take your denominator and set it equal to 0. Solve for x. Add 7 to both sides. Now again, x equals 7. If you draw that, that is a vertical line that goes through x equals 7. Horizontal asymptote is the number at the end, y equals negative 2. Question number 2, we always start with taking our denominator and setting it equal to 0. Okay. Subtract 8, divide by 2, x equals negative 4. Okay. And my horizontal asymptote is always the number at the end, y equals 5. Now something that I want to talk about here is this negative sign. That negative sign, if I distribute on the top, that means this graph is a negative. If I were to graph it, x equals negative 4. So here's an asymptote. Okay, y equals 5. Here's an asymptote. Now this is the first one that we've seen that the branches are going to be, they're negative. So it's going to go in these two quadrants. I know it doesn't ask us to graph it, but just so that we have an idea of what that would look like. Now we're going to talk quickly about the transformations. Transformations is, how is this graph shifting? So what is your A, your B, your H, and your K? So we'll just do a couple again. So the parent function is y equals 1 over x. This is your A. This is bx minus h, and this is k. So, in this problem we have a is 3. Don't forget h always lies to you. So h is not a negative 7, x is really a positive 7. And your k is a negative 2. What do all these do? Well, a causes a vertical stretch of 3. H goes left and right. It's a positive 7. It's a right 7. And k, that negative 2, means the graph went down 2 because k makes the graph go up or down. Okay. We're going to quickly go, we'll just jump to number 4 real quick without me writing this down. Let's just talk about it. Vertical stretch of 2. This always changes sign, so it's really a left 8. And this graph would actually go up 1. Okay. So that is all for this section. Again, domain, range, asymptotes, and transformations. Hope you guys have a great day. Subscribe to this channel. If you have any questions, you can send me a message and I'll be glad to help.